Hey y'all, let's take a look at a couple things today. And first off, let's dive right into greater than. We know how to write greater than. It looks like this. And if you have two numbers, how do you know one is greater than another? Well, one way to look at it is if it's on a number line, no matter where it is. Let's say you have a number here and a number here. Well, we know any number to the right of another number is greater than, okay? And your book talks about the new math, which came out in the 1960s, and it was supposed to be a way to, like if kids saw these two numbers, and they couldn't figure out why -4 was actually less than -1, or -1 was greater than -4 until we came up with these symbols or whatever. But anyway, we're going to look at a couple of inequalities in a second here. Then let's look at one. Again, on these, make these as fast as you possibly can. Make these some of the Saxon problems that you zing right through on your problem set, so you can spend more time on the other ones. But let's do a couple of these here. We're going to graph this, and it's going to be x is less than 3, and we are allowed to use positive integers. Well, if we're allowed to use positive integers, in other words, the domain is positive integers, less than 3 means this. That's going to be here, and it's going to be here, and that is it for the positive integers. You can't keep going because 0, -1, and so on are not positive integers. So we're not allowed to use reals, just positive integers. All right, here's another one. X is greater than -3, and we're allowed to use all real numbers. Well, if it's greater than -3, it looks like this. We're going to open circle there. And all real numbers means every single number, even ones between the integers. All right, here's another one, and let's talk about it very quickly first. Look at that title. In the book, it talks about the trichotomy and the transitive axioms. Well, trichotomy axiom says this in a nutshell. If you have two numbers and you compare them to each other, there's only three things that can happen. Either they're equal, let's call them A and B. Either A is equal to B, A is greater than B, or A is less than B. Okay. The transitive axiom basically says something like, if A is greater than B and B is greater than C, then A is also greater than C. We'll talk more about that later. But for now, let's look at the three possibilities one. This is the trichotomy one. In this one, you notice we don't have just a simple x is less than or equal to -4. We have x is not less than or equal to -4. So if you have a number that is not less than another number and it's not equal to another number, then it has to be greater than, right? So we can rewrite this inequality as this. In other words, we're not going to graph that. We're going to graph x is greater than -4. Okay, so let's do it. We are allowed to use negative integers in this one. So if it's greater than -4, it's going to be -3, it'll be -2, it'll be -1, and that is all we're allowed to use. So we just stop right there. All right, here's another one. This time, -x plus 4 is not greater than 2. So what we can do is we can say, okay, well, if it's not greater than 2, then it must be less than 2 or possibly equal to 2. All right, and we've done ones like this before. So we just move this over here. We have a -x. That stays less than or equal to. The 4 gets subtracted from 2, which gives us -2. And remember our rule, if we have to divide or multiply by -1 for an inequality, in other words, this will be positive x, this will be +2. Remember what happens here. This flips. So it's x is greater than or equal to 2. What are we allowed to use? Reals. So here we go. It can be equal to 2. It can be greater than 2, so it looks like that. There you go. Okay. All right, let's try another one here. And same thing. If you have an inequality and they tell you that it is not greater than or equal to, then we know it is less than -2. Okay, so we'll go ahead and move this over here. And that gives us -x is less than -2 plus 4. And of course we divide or multiply, whatever you want to call it, by -1, which gives us x, gives us -2, and gives us greater than. So x is greater than -2. We're allowed to use negative integers only. not real numbers, just negative integers. So x is greater than -2, well, there's a -1, and that's it. That's all we have. That's the only thing that fits the negative integer. We can't keep going over here to the right because those wouldn't be negative integers. So, okay. All right. Well, let's look back. Let's think back for a second. And this is called irrational roots. Roots, don't forget, it just means answers to an equation or equations. Irrational, remember what a rational number is? It's just a number that you can write as a fraction, right? An irrational number, we have two basic types of irrational numbers that we come across in math. One of them is pi, that's the most famous one. And the other one is the square root of some number that doesn't give you an integer as an answer. In other words, like, you know, the square root of 11 or something like that. A rational number can be expressed as a ratio. In other words, it can be expressed as a fraction, okay? So we're going to get answers to these problems that are not nice, simple fractions that are able to be, or numbers that are able to be expressed as a fraction. And you'll see that in just a second. But remember how we did this before. We went and graphed this. And okay, x squared plus y squared equals 9. You don't have to know this yet, so don't sweat it. But remember that this was a circle, and the 9 was the square of how big the circle's radius is. So we could just go like this, kind of, and draw kind of a circle there. Well, you know, that wasn't too bad, except for that bottom part. Okay, so that's the first one. Y minus x equals 1. Let's go ahead and just rewrite this as y equals x plus 1. And we know how to graph that, right? It starts here. That's our y-intercept, right? Oops, right there. And our slope is 1. So there's 1, there's 1, here's 1. You know, we can just go like this. And that's our, I tried to get an 8. And you can see that there are two answers to this thing. Well, one set of answers, in other words, an x and a y coordinate is right there. The other one is right there somewhere. Okay, so those are our two answers. Now, again, the only problem with this is that, you know, good luck trying to figure out where exactly that is. You know, I mean, it just isn't going to work. But don't forget, anytime you have a system of equations, you can graph it and find the solution. We tried it. I don't know what, you know, even if you drew a perfect circle, you wouldn't be able to figure out what the two sets of answers of x and y were. The second way is elimination. You can go, oh, okay, I'm just going to add these down and then subtract, but remember, you can't, these are not like terms. X squared is not the same as an x. You can't add or subtract this. So we're out of luck on those two. We're going to have to use substitution on this. And if you remember last time we did this, what we did was go ahead and go, okay, well, we took this second equation, rewrote it like this, then we went ahead and just squared it, right? So y squared is going to equal x plus 1 squared. Okay, so we can actually go ahead and write y squared equals, and we can do this in our heads here, x plus 1, you know, times x plus 1 is what we're looking at, really. Okay, so the first part is x squared, then x times 1, which is 1x, then, you know, another 1x, that's 2x, and then 1 times 1 is 1. So there we go. So y squared is the same thing as this. So we're going to put this first equation over here, and we're going to rewrite it as x squared plus, not y squared, but this here. So that's another x squared, and a 2x, and a 1, which will equal 9. Now, I don't know if you remember last time, we didn't, you know, we got a 9 last time in a problem like this, so these kind of canceled out. Won't do it this time. But let's see what we have here. We got 2x squared plus 2x plus 1. Okay, that's not going to cancel out. Let's just move the 9 over here. So 1 minus 9 is -8. That equals 0. Okay. Now, if you notice, on all three of these are divisible by 2. So let's just simplify this equation. So we have x squared plus x minus 4 equals 0. All right, how's that look? Okay. Now, if you look at this, we know this is a quadratic equation, and we know how to solve this. We can either factor it, or we can complete the square, or we can just use the quadratic formula. That's the easiest way to do it, if you'd like to do it that way. And if you do remember the quadratic formula is x equals -b plus or minus the square root of b squared minus 4ac over 2a. Okay, all right. And we can just call this a 1, that's a 1. We can just plop this in here and see what we get. Okay, so negative b is negative 1 plus or minus the square root of b squared is also 1 minus 4 times a is 1 times c is negative 4. This is all going to be over 2 times a, or 2 times 1. Okay, so over here we get negative 1 plus or minus. Let's just go ahead and do this in our heads here. We have negative 4 times 1 is negative 4. Negative 4 times negative 4 is 16. So 1 plus 16 would be 17. It didn't need the gigantic square root symbol there, I guess, but all over 2. Okay, so there are our 2 answers for x. All right, there are our 2 answers for x. Those are our, in other words, this set of 2, don't forget, one's a plus, one's a minus. They're going to be the 2 answers, in other words, the 2 x coordinates. How far over do you go for this one? Well, you go negative 1 plus the square root of 17 over 2. How far up would you go? We'll find out. How do you go for the other one? Oh, we go over here. That's going to be negative 1 minus the square root of 17 all over 2 and so on. We'll see what we get for y. Anyhow, the way you get y is you plug this back into one of these original equations. You want to do this one? Go right ahead. You can also, you know, jump off a building or something like that. But I'd rather do this one, way easier to piddle with this. So we can go ahead and just go, you know, let's go back to what we did a minute ago and just got this by itself here by saying y is equal to x plus 1. Okay, well, let's try the plus first. In other words, don't forget we have 2 answers for x. We're going to plug in both of those and we're going to get 2 answers for y. And that's going to give us 2 x's and 2 y's, which means 1 x and a y and then another x and a y. And one of those x's and y's will be that point. And one of the other x and y will be that point. What they are, no idea, but it's pretty simple to plug that on in. So let's go ahead and do the first one. So we'll do negative 1 plus square root of 17 over 2. So we got the first one will be y is equal to negative 1 plus the square root of 17 over 2 and then plus 1. All right, I'm not going to write plus 1. I'm going to write plus 2 over 2 because we're going to get those you know, fractions together. All right, well, you know, in other words, we have one fraction now. Y is equal to negative 1 plus 2. Well, negative 1 plus 2 is just 1 plus the square root of 17 over 2. And that's the y value. That's one of our y values. All right, so if you go negative 1 plus the square root of 17 over 2, you go, and they go right there. Okay, all right, so the numbers for x and y are actually the same. All right, for the other one, we're going to do exactly the same thing. Y is equal to x plus 1. This time, we're going to use the minus. All right, you probably can already see what's going to happen here. We'll say y equals, this time we'll say negative 1 minus the square root of 17 over 2 plus 1. And I'll go ahead and write, I'm not going to write plus 1, I'll just write plus 2 over 2. And this will be a 2 here minus a 1. That'll also give us a 1. But this time it's going to give us a minus square root of 17 over 2. And that is your y. Okay, let me take 30 seconds and sum this up again. When they say solve, you have a system of equations. You have 3 choices. You can graph it and try to figure out where the 2 shapes intersect and see what your answers are. That, good luck. There's no way, I don't know any human that could tell that from just looking at that. The second way is to eliminate. Well, we can't add these up or down because they're not like terms. So we have to substitute. So we take the y, turn it into y squared, and figure out what it is, like this. And you stick it back into here, and we get this equation right here. And you know, we figured all this kind of stuff out. We divided by 2. By the way, if you hadn't have divided by 2, you would have got exactly the same answer, but you would have got a different fraction. But if you had reduced the fraction, it would have given you exactly the same 2 answers there. So it's okay. Once we did that, we went, yeah, I can try to factor. Nope. I can try to do the, by the way, if you want to do completing the square, be my guest. Go right ahead and do it. It'll work. Or you can just use the quadratic formula right here. We used it. We got, since we have a plus or minus, we got two answers. They're the wacko answers. They're irrational. The square root of 17 is not a rational number. You can't make a fraction out of it. Over 2. We plugged both of those in one at a time. One time we did the plus here. One time we did the minus here. That gave us two answers for y, because they have to have two answers for y, because that's, it hits it right there at an x and y, and it hits it right here at an x and a y. So we have to have, if we have two x's, you have to have two y's. So there you go. Okay. All right. Only thing that's different is that the answers are not rational numbers. So okay. All right. Try A. Go ahead and pause it there and try A. Okay. Well, the way we write this is we go negative x. If it's not less than or equal to, that means it's greater than 4. Okay. And of course, we know that we have to divide or multiply, whatever you want to call it, by -1, which gives us an x, which gives us a -4, and which gives us a flipped sign, which is less than. Okay, so x is less than -4. You are allowed to use integers. So you go x is less than -4, you go, okay, fine, I got this, I got that, I got that, and it just keeps going on and on. That's all you have to do. Okay. All right, flip it, excuse me, flip it, don't flip it. Pause it and go ahead and try B. All right, I'm not going to bother to even, graph this. There's no point in figuring out, because I know doggone well I'm not going to be able to look at, some graph and tell exactly how the 2 points or the two shapes intersect. So anyway, all right. Well, let's go ahead and mash this together here. If y is equal to x plus 1, that means that y squared is equal to x squared plus 2x plus 1 if we go ahead and multiply it all out. All right, that is what I'm going to put right here. Okay, so let's rewrite the equation. So we have x squared plus this up top, x squared plus 2x plus 1 equals 11. All right, well, I have a 2x squared. I have a 2x. And I'm going to go ahead and mash this 11 over here. So I have a -10, that equals 0. All right. And I notice that all three of those terms are divisible by 2. So I'm going to go x squared plus x minus 5 equals 0. Okay. And here's where my nice quadratic equation comes into play. Okay. So I go x equals -b plus or minus the square root of b squared minus 4ac over 2a. All right. All right, so let's use that and figure out, I got a 1 there, I got a 1 there. So let's figure out what we got here. So x equals -b, so that's going to be -1 plus or minus the square root of b squared, 1, minus 4 times a times c, which is -5. Here we go. All over 2 times 1, which is 2. All right, one more time. We got -1 plus or minus the square root of, let's see, I got -4 times 1 is -4. -4 times -5 is +20. 1 plus 20 is 21. There we go. That's all over 2. And again, just to, to talk about how these are not just some random numbers. I mean, those are the two x values, on the graph where these two shapes will intersect. Okay, so there are your two x values. If you have two x values, you're going to have two y values. All right, so let's do the two y values. So here they are. We can use this right there and just plop that x right in there. We'll do the plus first. So we'll do that one first. So y is equal to -1 plus the square root of 21, which is, all that, over 2, and then plus 1, right? I'm just going to go ahead and skip a step here and not write +1. I'll write +2 over 2. All right? Well, then that's pretty simple. Y is equal to -1 plus 2 is just 1. 1 plus the square root of 21 over 2. There we go. That's my first y. And I'm assuming you can probably see what's going to happen here. In fact, if you want to take a shortcut in this case, go right ahead. You're welcome to do that. Because this is going to be, since this is 1 plus the square root of 21 over 2, since this is going to be negative 1 minus, well, you know, we'll just go ahead and do it for the sake of whatever. So y equals negative 1 minus the square root of 21 all over 2 plus 1, which is also, of course, 2 over 2. Okay? And this y value will be negative 1 plus 2, which is 1, minus the square root of 21 over 2. And you'll get to a point in this book where you recognize that this is how the y answer is going to work out, so you can just go ahead and just, you know, step on it and get that out of the way. So anyway, okay, that is how you solve those. See you guys next time.